Yeah, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahrul Irfan, and today I would like to present my simulation for my final year project. And I will be using PC1 as my software. Okay, my objective of my simulation in first one is to simulate the effect of the nanomaterial based or ARC on the PV module performance in terms of efficiency. Second one is to investigate the effect of the using different ARC material to performance of PV module. And the last one is to investigate the impact of using of different double layer ARC with different configuration on PV module performance. Okay, this is inside our software, which is PC1D. So they have a 5 part, which is first one is device, region, excitation, result, and the last one is a device schematic. So device schematic is represent our solar cell here. So the blue part, which represent as a PN junction, and the which mean a P-type region. I'm sorry, and the red one is represent as a N-type region. So the all parameter that I use in my simulation in the device, region, and excitation, I have to refer the previous report in the previous research. So I use the data from the previous research. Okay, first we have to do the simulation without solar cell without ARC. So we have to click the front surface optical coated, and there is two parameter that we have to manipulate, which is a thickness and the reflective index. So the way we have to setting the solar cell without ARC, which is we have to use 1000 nanometer thickness and one reflecting index as represent as a thickness reflecting index of air. So after we run it, we can get the three parameter that we want to observe, which is I short circuit, P maximum, power maximum, and the last one is V open circuit. And also we can get the IV curve here, which is the red one. So after get the data, we put inside of the table, and we can get all three parameter that we want to observe. After that, we can calculate the fill factor and the efficiency using these three parameter using the formula. Okay, this is how we calculate the fill factor by using the FF equal to P maximum over VOC multiplied by ISC. After that, we get FF, we can get the efficiency by multiplying VOC multiplied by ISC multiplied by FF over with P input. After that, we continue the simulation with the solar cell with single layer ARC, which is with the same nanomaterial. The selected material here is silicon nitride. I choose the different thickness that vary at the wavelength of 300 nanometer to 1000 nanometer. Okay, we use the thickness at the 300 nanometer, which is this value for our first single layer. Our outer layer is represent our single layer. So this is our first step to do the simulation with a single coating. Okay, here the result after running it and the IV curve. Okay, after that I repeat the same with the different wavelength and get the all data that we want to get into this table. So this is the IV curve for the solar cell without ARC and with silicon nitride. Okay, the second simulation we use is we use the single layer ARC, but with different nanomaterial. So we have a 4 type of nanomaterial here, which is magnesium fluoride, silicon oxide, aluminum oxide, and silicon nitride. Okay, then we inside the thickness and the reflecting depth for the different material, which is I choose the first one is magnesium fluoride. After that, run it and get the result, the parameter and the IV curve. So after that, we repeat with the different material and get the data, and we can plot the graph for IV curve and see the difference between with and without coating. So after that, we jump to our last simulation, which is we have to simulate the solar cell with a double layer ARC with using the different combination and configuration. So we have 12 configuration and combination here. So I will choose the highest one for this simulation, which is the magnesium fluoride and the silicon nitride. So in this simulation, I will put the outer layer and the middle layer as our single and double layer. So this represent our first layer, which is outer layer, and the second middle will be present our second layer. So we just run it, and then get the data of the 3 parameter and the IV curve. Okay, then we have to repeat with the different type of configuration and combination for ARC, double layer ARC, and then put the data. This is my result, and then uh, this is a IV curve for the our simulation. We can see the difference between the current compared with the solar cell without using ARC, which is there's two type of answer here. First one, we got the current is higher than without ARC, and the second one is current is lower than without ARC. So the answer to this problem is we have to look the deviation of the reflectance of our wavelength or for ARC. S- So first of all, I will use the magnesium fluoride and the silicon nitride double layer to see their reflectance in the performance in the software simulation. So we run it and see the yellow one is represent the reflectance, and then I just switch the first layer and second layer and to get the result. Okay, so here is the resultant reluctance for reflectance for our second configuration. Okay, as we can see here, when we use the bare silicon only, the reflectance higher than 30%. But when we use a good double layer ARC, which is for example magnesium fluoride and silicon nitride, which is lead to lower reflectance than when we use when we not use the ARC. And when we apply the difference configuration, which is we switch the configuration for silicon nitride and magnesium fluoride, we can see the curve for the reflectance are increased, which is the value for reflectance at that wavelength increase. So it's more than without you using ARC. So which lead to the increase in efficiency and current compared with not with using ARC. So the conclusion for my simulation first, when we use single layer ARC, it can improve our performance, which improve in my simulation from 2.28 without ARC to 3.262 3.262 alongside with the efficiency increase about 70.65%, 64%. So the second one is even we use the different type of material of ARC, it will lead the efficiency to increase due to their function. And the best type of choice for ARC material to be applied on the solar cell is silicon nitride. So for the